Good afternoon all. I'm building this. It's a 40-bit shift register because I want to do a video on linear feedback shift registers. I've done several before actually, but not one where I've got a nice long shift register and I can sort of go into the detail of how a linear feedback shift register works on a long register. I did a very detailed video, which I'll link up here actually, with a very short register. I think I only had 2 bits and then expanded it to 4 or something. But I wanted to build this, and on the face of it, it should be fairly simple to lay this all out on breadboard, but it's actually proving to be a real pain. One of the problems is that the 8 outputs of the shift registers aren't on the 8 pins on one side of a chip, and that's not surprising because typically VCC is on the top up there, top left, and ground is on the bottom right. VCC will be on the highest numbered pin. The lowest numbered pin, of course, is in this bottom left-hand corner. Ground is over on the bottom right. So that's what they've done. They've put ground on this bottom right, which means that you don't have a nice linear flow of 8 bits being able to directly drive LEDs. Now I've got 5 8-bit shift registers here, so that's 40 bits of output. I've got 4 10-bit of these blue bar graph LEDs, which are stacking. You know, they line up in a really nice, neat line. But I've had to use resistors to jump across this gap. I was actually hoping to use these displays across this gap between these 2 breadboards, because it just so happens if you take off these power strips on these 800 tie point breadboards and link them together here, that spacing is 300 mils. So this display would sit across there, but I can't do that because of this ground pin here, which I can't connect ground into one of the LED, or what would it be, anodes. That just wouldn't work. So I've ended up having to use 40 in total, but 35 resistors here, and I just used what I had. I'd had these 68 ohm resistors. I think it was Mike Harrison of Mike's Electric Stuff that said that actually you can get away with HC595s driving LEDs directly with no resistors, even at 5 volts. But since I was jumping these gaps, I thought I might as well use these resistors that I found in a drawer to act as the jumpers in effect. Now the 8th output is up here on pin 15 it is, so I've got to jumper that across onto the most significant bit of the shift register, and it's just a mess if you look at it from this angle. I could cut these down a bit and have them sitting a bit lower, but it's just not neat. Well, now I've got the problem that all the, or what would it be, pointing downwards, isn't it? All the cathodes of these LEDs need to be tied to ground. Now, well, here's the ground rail here, but there are gaps in it, so I can't just put in 40 links all going down onto this ground line. I'm going to have to put, I don't know, 30 something links in, and then little jump across links. And I did think maybe I'd try using single inline resistor packs for this, but actually even that doesn't work. Nothing on this breadboard design actually works neatly. It's just a mess. So these single inline resistors, this one I think is a 330 ohm, which would probably still leave these fairly bright. I think I've got some lower values of these somewhere. I'd have to dig them out. But if I put that in here, I've got to put it in so that the 8 pins, because these are typically 9 pins, I'd have to have the 8 pins against the first 8 of these LEDs, and then the 9th pin, which is the common pin, which will jump across to ground, sitting to the left there like that. So that's fine, but then when I get to the next 8, I'd probably have to bend the common pin up, because of course I have to have resistors going to the next 8 LEDs, and the common pin there doesn't go anywhere clever. I really want it to come out and be on the same pin as this common pin over here. What I really want is a single inline resistor pack with 40 resistors and 1 common pin. It would be a 41 pin single inline resistor pack, and you can't get them. And although I could bend pin 1 out so that it doesn't go into the breadboard, the problem is every time I put a new resistor pack in, let's get another one. What's that one? I think these resistor packs came out of disk drives, probably old floppy disk drives, maybe even hard disk drives. They were the sort of termination resistor packs. But anyway, so the next one would have to go there. I don't think it could go behind, because if I put it behind, then I can't bend that out. I'd have to bend it right round and up and pretty much destroy these sill packs. And I'd have to solder wires on and have them sort of daisy chained onto pin 1 of each of the sill pack. So that one's going to have to go in front there. And now I've run out of space. I can't put another 2 packs in because I haven't got any more of these lines. So this just isn't working out at all well. I think I'm going to have to do this either with discrete resistors like this, but actually even that doesn't work, because where there's a resistor missing, where this gap in the negative line is, I'd have to join 2 of the LEDs together, but then they're sharing a resistor and their brightness is going to vary depending on whether 1 or 2 or 0 LEDs are switched on. So it just doesn't work. I think this is going to have to be all wire links. I'm going to have to bend, I don't know, 35 wire links, bring them all down onto this 0 volt line, this blue common power rail, and then where there's a gap here, put a little jumper link across there. It's just going to be a mess. And you'll notice that these resistors are all angled because they sort of stagger by 1, and that's so that I could line the LEDs up exactly with the chips. But of course they're all offset slightly because the most significant bit here actually goes to pin 15 up there, and then pin 1 goes to the second LED. So the only way it would work is to shift the whole lot of these left 1 bit, and that kind of just offended my OCD and my sort of sense of everything lining up, so I didn't do that. Now had I done that, I might have been able to use these things, which are, I think, I'd have to check it, I think they're resistors running across. This says R33, so I'm not quite sure what value they are. I think they're resistors, 8 resistors running across, but that wouldn't work because I don't want the 8th resistor. So I'd have to try and find 7 resistor packs, and you can get them. Here's an old 7 resistor pack that I've found, but I've only got the 1. So you can see that it's definitely 7 resistors there. I have no idea. Oh yeah, look, its number starts with a 7 and this one starts with an 8. I have no idea where this came from. I don't know what value it is. And of course, I've certainly not got enough of them to put these nice, neat 7 packs in. These 8 packs, incidentally, won't stack end to end because they just have too much overhang. And if you stack them end to end, let me see if I can find another one. Well, actually, it's this type that I've got most of. This looks like some sort of ceramic thing. I've got 82 ohms there, and this one is 22 ohms. But if you stack them end to end, you can see that they don't actually stack with a constant spacing. They're actually going to foul each other. Now, I did think if these are indeed resistors jumping across, that I could just snap the ends off them. But the likelihood of me breaking the last resistor off cleanly without destroying resistors further down the pack is pretty slim, really. Now these straggly bits of peel off sticky tape are a bit ugly, so I'm going to peel those off so that this looks nice and neat for when I present it in the upcoming video, if I can get that stuff to peel off. And because nothing I was doing on this array of shift registers and LEDs would line up neatly with the breadboard, I started to think, actually, this is one of those situations where it probably would be better to have a PCB for this, actually design a PCB and, I don't know, send off and wait for it to arrive and then do the video. I did actually buy a PCB for 74HC595s, but it just isn't quite right. It's only got 4 of them for a start, and I wanted 5 so that we get 40 LEDs, which lines up nicely with the 40 LEDs in these 4 10-way LED packs. But yeah, they've got power rails running down the middle here to VCC and ground. That's pin 1 there, I think. They've got the output of the 7th shift register or the 8th shift register, depending on which way you look at it, linked across to the input of the next one, so on. They're sort of daisy chained. So they've done a lot of the hard work on this board. This came from MaximumOctopus.com. Bought this some time ago. It was from a UK seller, I think. Someone had designed this HC595 shift register board, but the shift register outputs just go to these 8-pin. Is that 8 pins? Yes, it is 8-pin outputs on which you're supposed to put some headers, I suppose. It just isn't. It's not designed for HC595s and bar graph array LEDs, so it's not really suitable. I'd have to design my own PCB and, as I say, send it away and wait for it to arrive. Right, so I'm going to need to cut lots and lots of this tinned copper wire to put all these ground connections on the cathodes of all these LEDs. I didn't peel that 4th peel sheet off, did I? You can just about see that shining in the light. Yeah, I've got to cut lots of this off. And then do I just bend loops the easy way, or do I bend them nice and straight, which I typically do over the side of this pair of pliers. I think that's about the gap. Yeah, I think that's the gap there. That works quite well. So that will form the bits of wire to sit along here. Let's do that now. I've got to straighten this wire. Now there are 2 ways to straighten wire. Either sort of put a slight opposite bend in, but it takes a while to get that exactly straight. Or the other way to do it is you can hold the wire with your pliers at one end and then you pull really hard and actually stretch the wire, and by stretching it, it reforms it in effect and it's completely straight. And then just cut the end bit off where you bent it and then cut this down into little individual pieces. Now, how big am I going to make these pieces of wire? Should we say 2 centimeters? So I'll cut them initially to little 2 centimeter lengths. It doesn't have to be massively accurate, but I want to make them reasonably neat because, well, the neater you make your layout, I mean, it's not neat, is it? It's just horrid. But the neater you make it, I feel the easier it is for people to see what's going on. Okay, so let's bend one of these over the pliers. So I've got to sit that reasonably central, bend it over there, and that creates my first link. Just see if it's formed straight. Give it a bit of a twist if it hasn't. And then I can place that in. So let's do the first one there. So that hasn't actually grounded the very last LED, so I have to put a little jumper link in there. And the jumper links I probably will do just by bending like so. Oh, that fell on the floor. Bending like so, and it just finds a sort of natural curve. And then I can pop that in there. I didn't bend that quite tight enough. Bend that a bit tighter. But yeah, I've got to fill this with little links. Yeah, bending these is pretty laborious. I've actually ended up bending them in pairs, sort of doing 2 at a time, but then they don't bend quite as squarely, so I'm having to just sort of square each one up and then put it into the breadboard, square that one up. It didn't bend quite square. Get it nice and neat, shove it in the breadboard and keep going. Well, I've decided to do the little single jump wires where there's no ground line there. I've decided to do it just on the very tip of these pliers, bend that over so I do actually get a straight formation there. Just square that up and pop that in there. And I just need to do that everywhere where there's a gap. So let's get that done. Right, now I need VCC and ground on these shift register chips, but that's going to be difficult because ground here I can't bring it down to this bottom area because, well, there are no holes left, and also I'd have to jump over the display, which I don't want to do. So I'm going to have a wire that jumps up over the chip and up onto ground at the top there, the minus line there. And also because of my there are two clock signals, one for the shift register and one for the output latch, I think it is. Is it? One's for the shift register, one's for the storage register. Yeah, you got the shift register, then the storage register, then the output tri-state device. So you've got to have two clocks which are opposite phase. You can link these wires together, but then you'll get the output will be what was on the previous state shifted through. And I don't think that's going to work for an LFSR. So I need two clock lines, and that's taken up all my space. Then I need the daisy chain from the QH dash output to the serial input of the next chip. That's also a problem, and it's also blocking my access to VCC. Actually, I can probably get to it there, but I'll probably have to have some sort of loop jumpers for VCC up to red and for ground up to blue. It's just going to look awful. Actually, there is a pin up on this top side, I think, which you pull low, or do you pull it high? I can't remember now. And that's the shift register clear. Well, it's active low, and we don't want to clear it, otherwise you just have zeros in here. So that's going to have to be pulled high. So that goes to VCC. That doesn't help me get my ground line up onto this side. Oh, output enable. Now that actually would have to be low, so I could probably jump ground up onto output enable and then take it to the negative rail. Perhaps I'll do that. Right, I've got some solid core black here, so I'm just trying to straighten that out by, yeah, that seems about right. So that has to go from pin 8 it is to pin 13, jumping over the top. So how long is that going to have to be? Let's try one at 4 centimeters, and then if that looks a bit large, a bit unnecessarily large, I'll try 3. Now I can't really use the Wycon wire stripper number 5 for this, because if I put that in there and strip it, it kind of, well, it sort of works, but it sometimes bends the wire where it does that stripping action. Let's try it again. Also, for some very strange reason, there's a gap where you feed that into the mouth there. There's a gap in the stopper, and it feeds right through the stopper. That's just really stupid. Why have they done that? So you're never quite sure. No, you see, that didn't strip back to the same length as that. Do you know, I think I might just not bother with the Wycon for this. It's just more trouble than it's worth, and I'll use this this one that just came from Wix. But it does mean that I'm kind of guessing. It doesn't quite fit through there either, so I have to open these out. I think I'm kind of guessing the length of the strip back, and it's much more difficult to pull it manually. Yeah, it's just not very satisfactory, is it? Okay, so let's put a little curve in that and see if that will hop across the chip. Oh, it looks a bit short actually. From pin 8, which is there, to pin 13. Kind of just about works. Yeah, okay, so I'll make a load of these. That gets ground at least over onto this side, and then I'm going to put a wire link up to the ground line up there. So I'll start making these now. Yeah, not brilliant. They started off sort of loop shaped, and they've ended up as a sort of flatter topped to get the span, because the loop one didn't quite. Oh, it's just turning into a right shambles, this. Right, 5 wire links for the grounds, which are these black jump over loops. I now need 5 more for the VCCs, but I'm also going to need 5 more to tie the shift register clear lines high, because we don't want that going active low. Right, that's all those links up the top there now. So I kind of want to see if this works. So I need to build a quick clock. So I'm going to put a pot on pins 8, 7 and 6 on the 7555. Oh, does that leave me room for a VCC link? Yeah, just about. Ground link, I'll need a capacitor and a link from 6 to 2. Right, I've kind of just bodged some wires into here just to get this working, because I'm getting pretty bored now, and also the light's going. It's getting dark, so I think I'm ready to put power to this now and see what happens. So, would you like to see that without a rehearsal? I'm just going to go for it. Well, there's no bang. I don't know whether that's... Ah, yeah. So if I induce... Oh, why has it not gone onto the second chip? So it's shifting down the first chip. I'm just inducing noise into there. It's probably almost like a mains frequency. But it's not shifting onto the next one. Have I not linked data out to data in? What have I done? I wonder if this is one of these... Oh, that's what it is. Yeah, I was just going to say, I wonder if it's one of these breadboards with the split power rails. And yes, they're split down here, so I'm not got any grounds going to these LEDs. This one has continuous red and blue lines, so I don't think they're split. So I'll just put a little jumper over there, which is a pain in the neck because that's on the negative. Actually, I can jumper it up there, can't I? Yeah, I'll do that. That should do it. Right, so that's jumpered it sort of there, just bodge jumpered it across that gap. So is that still on? Yes, it is. Oh yeah, and that's travelling all the way down. That's good. So that's with me just inducing noise, because this is a CMOS input. Of course, it's very susceptible to noise. So there's probably some relationship between the frequency of my clock and the frequency of mains that's giving rise to that pattern. Actually, it's not a bad pattern. That's probably one of the best ones I could find. But equally, I could put a positive in there and just fill the thing up with light. Or I can put that on negative. Oh, that's back in positive. Put that on negative if it'll go in the hole. Get in there. And yep, that fills it up with nothing. But actually, no, that's good. Just feeding induced noise into there. It's giving a really interesting pattern. And from my point of view, the shift register is working. Let's just zoom in on that a little bit. Yeah, that's working. So that's good. All the LEDs are in a nice, neat line. So yeah, that's going to make a good linear feedback shift register video. Just at the moment, I linked the two clocks, the shift register clock and the storage register clock, because it doesn't actually matter if it's one bit behind, but it will matter when it's a linear feedback shift register. But yeah, okay, so I'm happy with that in principle. Let's put that on a ground line. But this is just a very unsatisfactory breadboard layout. Cheerio.